Okay, so this is 9.7 homework quiz, and it's a good little practice. So for someone who isn't in class, I'm going to put this video up. Anyway, so for the first one, what do we see in front of us here, Tara? What do you call this?
It's a
Okay, and it's what falls under what pattern that we saw yesterday? The difference of perfect squares. Good. Everyone say it. The difference of two perfect squares. So you said it right. It becomes the sum and difference pattern. So what do you have?
2 and then plus 10.
Good. Okay, so you basically take the square root of the first term and put those factors there. Take the square root of the last term, put those factors there. This is an n. And then in between we have the sum and difference. The way I like to look at this is when you have the difference of two perfect squares, you end up with a wider looking factorization, right? Like an upside down funnel, okay? It's the reverse when we see this pattern, number 2. What do you call this number 2? This is a what kind of trinomial?
Perfect square.
Say it louder. Perfect square trinomial. Everyone say it. Perfect square trinomial. We know that because the first term is a square, perfect square. The last term is a perfect square. And we have the middle is 2ab, right? So what do you get, Kelly?
You get x plus 3 squared.
And look at this. This becomes a reverse kind of funnel, right? So we go from a trinomial down to a binomial that's being squared, but it looks like a funnel the other direction. Okay? So this one is like a funnel this way, this one is like a funnel this way. You start with a trinomial, you get to a binomial that's squared. Got the idea? Right? What can we do with number 3? What do you do first with number 3? Do you see it? Jocelyn?
You have to find the root.
Good. You can factor out some greatest common factor. And what is it? 4. Now, it looks like a perfect square trinomial anyway because the 4 and the 16, but it would not be completely factored if you don't pull this 4 out. So good. So she says pull out a 4. I'm going to come over here to do this. 4. And what do you have left in your trinomial?
Y squared minus 4y plus 4.
Good. And so now when we look at this inside trinomial here, what's left? Is that a perfect square trinomial?
Yes.
So what are the factors then?
Y minus 2.
Y minus 2 squared. Good. And again, to confirm it, the first term squared is y squared. The last term squared is 4. And in between, we have y times negative 2, negative 2y twice, which is negative 4y. Good. We didn't say that here, but we could do the same. We have the first term squared, we have the last term squared, and in between we have 3x twice, 6x. Good. And now we have number 4. What strategy might we use for number 4 right after that? Talia.
Multiply by 4.
Good. She wants to multiply to get rid of the fraction. What would you multiply by?
4.
Good. So multiply the entire equation, which means every term. Yes. Even that you must, what you do to one side of an equation, you have to do to the other. It doesn't look like anything because it's still 0. But what does the equation become?
4x squared plus 4x plus 1.
4x squared plus 4x plus 1. Okay, is this a perfect square trinomial?
Yes.
It ends up, then it is. This is a perfect square, this is a perfect square. So what are the factors, Talia?
2. No.
Say it?
Yeah, 2x. And then
Plus,
plus 2x.
what's the square root of 1?
1.
1. Squared. Now let's make sure. The first term squared is 4x squared, right? The last term squared is 1. And what is 2x times 1 twice 4x? Yeah, so good, we have it. So what is this? This is just a single binomial happening twice, right? The square of a binomial. So there's really only one solution, and what is it? You were asked to solve it.
Oh.
So you're saying, what would make 2x plus 1 equal to 0? And I hear some of you saying it. Good. Subtract the 1, divide by 2. So x equals negative 1/2. There it is. Okay? Who was able to take it all the way to the solution?
I just forgot to.
Who just stopped at factoring? But just because we've just been doing a lot of factoring, you might have.
I got it.
Good. Okay, and then finally, the last one, without even giving you the formula, who thinks you have the answer? You do? Okay, so JD, how'd you set it up?
So 9 equals negative 16t squared.
Say it again.
9 equals negative 16t squared.
So you put, give me the formula for the,
H equals negative 16t squared plus bt.
okay, so what's the starting height of this thing? 9, so where does it go?
And the h.
It actually goes in the starting height, the S, 9. Okay, now, the initial velocity is what? 0, so we can just kind of wipe out the middle. We don't have a middle term. 0 times t is 0. And so we still have negative 16t squared plus 9. And now what is the ending height if it hits the ground? 0. So you might just have a negative issue or something. So now, to solve this, what would you do?
So now you can take out the negative from the 16. So you have negative 1 parentheses. 16. No, sorry, 4. Or yeah, no, we're
Just take out the negative.
Yeah, and then plus 9.
It's actually minus 9, right? Negative 1 times this gives you back negative 16t squared, and negative 1 times that gives you back the positive 9. Okay, so there's what we have. Is this the difference of two perfect squares? So we're going to get, pull a pattern out, right? We're going to get negative times the sum and difference pattern, right? We're starting from a binomial here. So we go out, we end up with a bigger, wider factorization. And so what is the square root of 16t squared? 4t, right? 4t. And what's the square root of 9? And so we have 3 here and 3 here. And what will the signs be? Sum and difference. Good job. Okay, so now we're not done. We need to know how much time it took this to fall. So what are the possible t's? In this first case, the possible t is negative 3/4 seconds. Is that possible? Not reasonable. Okay, so we're not going to use that solution. And this one here is 3/4. So is that reasonable?
Yes.
There it is. It took 3/4 of a second for the apple to hit the ground. Very good. Good practice.